Okay, so here we have some synthetically generated data on the default for a certain set of loans, and we also have some input parameters such as the borrower's credit score, their debt to income ratio, their annual income, their loan to collateral value, their age, their previous defaults, as well as the GDP growth rate at the time of making the loan, the unemployment rate, and the inflation rate. And we have thousand such data points, and let's try to see if we can draw any statistical conclusions from this data. And we're going to launch this analysis from scratch. First, we will load this data into our tool here and ask it to conduct a exploratory data analysis to understand what this data is all about. And here we see that the AI tool is itself trying to interpret what an exploratory data analysis could mean, and writing out the code to first obviously load and creating this plan to do various things, which includes data feature engineering such as checking for missing values, uh, uh, analyzing categorical variables, and then performing correlation analysis on numerical features. So with this plan in place, it's also going to write out the code to do each of these things and then run that code as well. So let's just give it a couple of seconds to see what the result of this code is. And while it's running, there's another interesting thing here, which is that at any stage if the code fails, because we all know, right, that Python code, first attempt never works. This AI system is smart enough to figure out the error, search online for the error and fix that error, and then continue with its analysis. So let's see. It says the exploratory data analysis EDA has been concluded successfully, revealing key insights into the dataset. The correlation matrix, distribution plots, and scatter plots provide a comprehensive view. Let's see. So we see here we have got the correlation matrix, which shows that what does it show? Uh, it looks like credit score is negatively correlated with default status, although not very strong. And then the debt to income ratio is somewhat positively correlated with the default. And interestingly, none of the other variables seem to have a very strong correlation. Okay. Looking at the distribution of default status, we see okay that bulk of the data items in our current data are actually not default cases. It is only a very small portion is default, which is true in any case, but I think this is telling us we probably need more default data to perform any meaningful analysis. Distribution of credit scores. Okay, so it has created the distribution of credit scores on its own, and we see that seems to be normally distributed. Age distribution is also available to us uh, in the box plot format. Age distribution for each default status, and here we can see what is the distribution of the age as per the default status. Nothing meaningful seems to come out of this though. Here we have a scatter plot of income versus credit score by default status. So again, we see that for the default cases, there really seems to be no meaningful correlation with either the credit score with annual income or credit score. Seems like higher annual income seem to have lesser defaults though, and lower credit score seems to have higher default, but nothing very strong. We also see the distribution of debt to income ratio, okay, and so on and so forth. So here we can, the interesting thing is we can ask it to do anything. For example, we can say, show me uh, the the analysis for GDP to default status. Right? It's just as simple as writing it in English, and then it'll figure out the plan, write the code, and go ahead and do that.